Let us look at proposition number 22 of book 6 of Euclid's Elements. The proposition says if four magnitudes are proportional, then the rectilinear figures similar and similarly placed upon them are also proportional. And if the rectilinear figures are similar and similarly described upon them are proportional, then the straight lines are themselves also proportional. So what this means is we have here A, B, C, D, E, F, G, H. If these lines are proportional, then the figures described similarly and similarly placed upon them are also proportional. That means this triangle is to this triangle as this figure is to this figure. And it doesn't matter what type of figure it is. And it talks of the converse also. That if these figures are proportional, then these are also proportional. So let's see how we can prove that. See, the first thing that we do is mention what is already known to us. We know that AB is to CD as EF is to GH. And we are given that figure KB is similar to figure LCD and figure MF is similar to NH. Yes, so these two are also given. Now, what we have to show is because AB is to CD as EF is to GH, that means figure KB is to LCD as MF is to NH. Okay, let's see how we can do that. So the first thing that we do is we find the O, the third proportional to ABCD. So we have AB is to CD. So we find the third proportional. Okay. Similarly, we find P, the third proportional of EF and GH. We know how to do that. I have done this here. That we have the third proportionals. We know that AB is to CD is equal to CD is to O. And similarly, EF is to GH as GH is to P. Because remember, O and P are the third proportionals. Since AB is to CD as EF is to GH, that means AB is to CD equal to CD is to O is equal to EF is to GH equal to GH is to P. So these two are themselves equal. Okay? Which means what? Which means AB is to O as EF is to P, X equally. Now, based on another proposition that we have already proved, AB is to O is equal to figure KB is to figure LCD. Similarly, EF is to P is equal to figure MF is to figure NH, which tells us what? That figure, because remember AB is to O is equal to EF is to P. So AB is to O is figure KB is to figure LCD as figure MF is to figure NH. So we have shown that if four magnitudes are in proportion, then the similar figures on them are also proportional. Okay, so that was the proposition. Now let's look at the converse of that. So here we start with the fact that these figures are in proportion. So figure KB is to LCD as figure MF is to figure NH. Now we have to prove that AB is to CD as EF is to GH. Let us say that it is not in proportion. These magnitudes are not in proportion. EF is to GH is not equal to AB is to CD. Okay, since we have assumed that EF is to GH is not equal to AB is to CD, let's find one more magnitude which is in fact equal to AB is to CD. EF is to the other magnitude is equal to AB is to CD. So for that, we have AB is to AB and CD, and we have EF. We have to find the other. So that will be our fourth proportional. So we know how to find the fourth proportional. So let's find that. This is our fourth proportion. And on this, we describe a rectilinear figure. Okay, remember, we are not copying this figure here. We are creating a figure on this similar to this. So now, so let's describe that figure. This is our figure. Remember, to create this figure, first we have to figure out QR, which is our fourth proportion. We are saying let EF is to QR is equal to AB is to CD, which means again, based on what we have already done here, if four magnitudes are in proportion, then the figures on them will also be in proportion. We apply that here. So we have four magnitudes. Yes, so that means the figures on them will also be proportional. So we are using this as one of the steps here. Figure MF is to figure NH equal to figure MF is to figure SR. How did this come? Remember, here we are starting off with the fact that figure KAB is to LCD is equal to figure MF is to figure NH. But here we are assuming that EF is to GH is not AB is to CD. But EF is to QR is equal to AB is to CD. So here we have this statement and we have this statement. Figure KB is to figure LCD is there on the left hand sides. So that means right hand sides will also be equal. So figure MF is to figure NH is equal to figure MF is to figure SR. Means what? If you notice, two figures have the same ratio with the third figure MF. If these two ratios are equal, that means figure NH is equal to figure SR. NH is equal to SR figure, which means what? If the figures are equal and they have been, and we know that AB is to CD is equal to EF is to QR, we know GH is equal to QR. Yes. So this GH is the same as QR. Now, since they are equal and we have this proportionality, AB is to CD equal to EF is to QR, we substitute this QR with GH because they are both equal. So we end up with our final conclusion that AB is to CD is equal to EF is to GH. In this proposition, if we are given that AB is to CD as EF is to GH, then the figures, similar figures on them are in proportion. And the converse, if the figures are in proportion, then the magnitudes on which they are constructed are also in proportion. So that was proposition number 22 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. Remember, in that book, proper references are being given to the previous. Here, I am just saying previous propositions. There, I am actually mentioning the proposition numbers and all. So that is today's session. That's it.